So foldable that you should have picked up, cut along the dotted line. These are two flaps. Now, log is short for logarithm, and like we were saying, these two functions are opposite functions. They are inverses. So logarithms, and exponential functions are inverses. They are opposite operations. This is key for today. This is key, knowing they are opposite operations. Just like square and square root are opposite operations. So, there are two ways that you can remember how to convert from one to the other. So say in this problem right here, we looked at this and we were told, okay, you need to solve for A. Oh, you're super late, like 4 minutes late. Okay, so say we were told that we need to solve for A. Can we just divide the log off of the A? Is log being multiplied times A? No. We're taking the log of A. That's the operation happening to A. Okay? So in order to do the opposite operation, what did we just learn is the opposite operation of logarithm? Yeah, the exponential, right? So in order to get the log off of the A, in order to make the A not be logged anymore, we need to convert to exponential. So either you can just remember, okay, going from log to exponential, the base B is still your base, you put on the bottom, and then what the log is equal to is your exponent, and then it's equal to what's being logged. Either you can remember the placement of these, or I like to do what is called the log roll. This is just something that I remember. Every time I'm going to try to convert from log to exponential, I remember to do the log roll. Now the log roll, you start at your base. You always, always, always start at your base. And then you roll towards your equal sign. So you go towards your equal sign, and you keep going until you've passed by all of your terms. So I go from B, I pass by X, and then I go to A. That's how I know I can stop my roll, because I've hit all of the terms I need to hit. So this means that I'm going to start with my base B, right? That's where I started my roll. Then I pass by X, so that's what I raise B to. And then I stop at A, so that's what it's equal to. And this will make more sense as we do it more. So let's try it over here. It says solve for X in the following operation. So what is the issue with immediately knowing what X equals? What's happening to X? It's being... What's happening to X? It isn't being multiplied times log, right? It's being logged. That's an operation, okay? It has log base 2 of X. So in order to separate the X from the log, in order to have the X not be logged anymore, what's the opposite of log? Exponential. So we need to convert this into exponential by doing our log roll. So I start at your base. Always start at your base. And you go towards the equal sign always. Start towards the equal sign and go around until you've passed by all of your terms. So this means that I'm first going to write my base. That's what I hit first. It's my base of my exponential. And then I pass by what term next? The y, so that's what the 2's raised to. And then I set it equal to my last stop. What did I stop at? X. I'm done. I've just solved for X. Log, the definition of log is literally that it's the inverse of exponential. It's just an operation. It's an operation that you're not familiar with. You've never been introduced to it before. But just like square and square root and multiply and divide, it's an operation. Raising something to the power of x is an operation. It's exponential. That's more easily understood than log, for sure. I understand that. Okay. So now, let's go the other way. We're trying to convert from exponential to log. You still do the exact same thing. You still do the roll. We start always at our base. And then you roll towards the equal sign and around till you've hit all your terms. So this means we're going from exponential. To get it out of exponential form, it needs to go into log. So you write log. And the first thing we hit was a b, so it's log base b of, and then we pass by a, so you write log base b of a, equals the last thing we touch, which is x. So let's try it. We're asked to solve for x. What's the issue with immediately solving for x here? It's in the exponent. So this is an exponential function. How do I get x out of the exponent? We have to log. We have to do the log roll, convert it into a log function. So I start at my base, roll towards the equal sign and around until I've hit all of my terms. So we started an exponential. I now need to make it a log, so you write log base 4. What's the next thing we pass by? Y. So log base 4 of y equals, and then what's the last thing we touched? 2x plus 9. Now, is x solved for yet? No, we still have things on the same side as x. So what do you think we need to do? Yeah, first we're going to subtract 9. So this is log base 4 of y minus 9 equals 2x, and then what? Divide by 2. So this is now log base 4 of y minus 9 over 2 is what x is equal to. I know you guys were, well, we'll keep doing this, and then in between the two foldables, I'll try to re-explain log a little bit like I did for the last class, okay? So, let's start this example number 3. What is different, do you think, about this example versus the prior example? Is the exponential term all by itself? No. So just like with radicals, if we had a radical plus 8, what would we have to do first to solve for that radical? Same exact thing here. So from here, I want you to solve for x. Okay. Mm-hmm.
So he did most of the test on his own, but then this part, he was talking to somebody else and got their information. So I told him I was taking off minimum 10.
Okay.
Do you think that that's a fair thing? Because he did most of the test by himself.
I think that's okay because you're taking off 50% of the portion. As I walked around, the one thing that I did see that people were doing somewhat incorrectly, they were doing the log roll correct. So they knew it was log base 2 of y minus 8. Stop right there. Are we just taking the log base 2 of y?
No.
No. What are we logging?
Y minus 8.
So in order to actually say that you're logging both the y and the negative 8, you must put it in parentheses. Then everyone divided by 3, and it was beautiful. Any questions so far? All right. Now take out your inverse function and domain and range of the inverse foldable. How do we find the inverse of something? Yeah, switch x and y. That's how we find the inverse. So, in our example, it says find the inverse of the following function. F of x is equal to log base 2 of x plus 3. What are we going to do first if we're trying to find the inverse of this? Yeah, switch the x and y. So this f of x is the same thing as what? Y. So this is where we're going to put the x now. And it's log base 2 of, what am I going to replace that x with? The y. Beautiful. I just flipped the x and y. Okay. So now, in order to find the inverse function of this, what is my next step? Yeah, why? Why am I doing log roll here? What am I trying to get by itself? Yeah, I'm trying to solve for y to get it back into an equation form. So I need to get the y by itself, but unfortunately that y is being logged. So what's opposite of logging? We convert it to exponential by doing our log roll. So where do I always start? The base, which is? 2. So start at the 2, and I'm going to go which way? Yeah, towards the equal sign and around till I've hit all of my terms. So how do I write this? Yep, base 2 raised to the x power equals, yes. Now is y by itself yet here? No. So what's my last step? Well, no, actually second to last step. So my function is now 2x minus 3. And then what is my final step? Right, you have to change that y out for the inverse function. And I'm done. Have I successfully converted from log to exponential? Is that an exponential function? Yes, it is. Right? It's raised to the x power. All right. Someone have an orange? It smells really good.
Yeah, sorry.
No, it smells good. So now, do you think you can do this? Yeah. First period did it, yeah. You guys go ahead and try to do number 2. Okay. So, in this problem, no, I paused it. Yeah. Oh, yeah, the live, yeah. All right. So, we changed the x and the y. Then we log roll, and we have log base 2 of x is equal to 3y minus 5. Now, we have already created the log, right? We are only logging what term here? The x. So when you go and add 5 over, you're adding the 5 after the log. So are you actually logging that 5? So do not put it in parentheses this time. You're not also logging the 5. Then everyone divided by 3. And we had log base 2 of x plus 5 over 3 is our inverse function.
And then do we put that in parentheses? The x plus 5 or
No, that's what I'm saying, no. Because we're not also logging that 5. It's just the x this time. All right, so now let's quickly go over the domain and range. Where is this function? Where has it moved? Where has it moved?
down 3.
Yeah, if we had a negative 3 after the x, that would mean we move to the right 3. It's not after the x, though. Where is it? It's on the end, which means up and down, right? So we're moving down 3, and we know, or we learned, some of us learned last class, that this is what an exponential function looks like that, right? With an asymptote at the x-axis. So now we're moving down 3. That means that I'm here. And I have an asymptote where now? Where did my asymptote move to? Negative 3. So that means what has changed? The domain or range? The range, right? My y values were brought down a little bit. So what's my domain? All real numbers. And what's my range? I start at, what's my lowest value? Negative 3. Can our function be negative 3?
No.
No, that's where the asymptote is, right? So I can never actually touch negative 3. So it's a parenthesis, negative 3 to infinity.
So if you were writing this in set notation, would you still write y and like x?
You would write y is bigger than negative 3 here.
You wouldn't have to put like y to the inverse.
No, it's just asking for the domain of the inverses.
So then it's implied. That
Yes. Okay, so number 2. Now this is a little bit more of a tricky one. Where has this function moved? So we learned, for those of you that weren't here last class, this is what a log function looks like, right? It's the exact inverse of what a exponential looked like. So an exponential was like that, right? So it's the inverse. Oh no. So where has this function moved from our parent function? Has it moved left or right? No, it's moved up. Now, the entire thing is being divided by 3.
So up 5.
Up 5/3. Yes, up 5/3. Now, guys, what are you doing? What am I doing? What am I doing? I've moved up 5/3. So is that actually changing our domain or range?
No.
No. What movement would have changed our domain and range? If I went left or right, right? It would have changed the domain. But I didn't. So what is my domain? Ooh! What is my domain? Yeah, 0 to infinity. Oh, close enough. No, that would have been wrong. And what's my range? This is all real numbers. Right? They're inverses. So all real numbers for an exponential, for the domain, all real numbers for a logarithm is the range.
So x doesn't touch 0, right?
What?
X does not touch 0.
No.
Because anything ever stay the same?
The all real numbers. Exponential will always have all real numbers for domain. Log will always have all real numbers for the range.
So it's like, depending on where the asymptote is, you'll either have all real numbers in the domain and all real numbers, or all real numbers.
Both of these functions always have an asymptote. So you will never have all real numbers for both domain and range.
Yeah. Okay.
Okay?